All right, here's a nice question. This one involves a limiting reactant, and then as part of the game, you have to determine how much of the excess reactant is left over. So you sort of have to do stoich twice. Okay, so let's, it says 3.25 grams of NH3, so mass 3.25 grams, and oxygen, the mass is 3.50 grams, and they say which is the limiting reactant, and then how many grams of NO are formed. So this one, they want to know what the mass of that is formed. Again, too much information, so it's a limiting reactant question. And so I want to know which of these are going to get used up first. So let's do that. So to do it, we can't compare grams, we have to compare moles, right? So let's figure out the moles of NH3. Yeah, well, I guess we should balance the equation first. Let's look at that. Hydrogens, there's 2, hydrogens 3. So maybe let's balance that. Let's put a 2 here and a 3 there. That gives me 6 hydrogens everywhere. Gives me 2 nitrogens. I guess I need 2 nitrogens there. But now I've got 2 oxygens plus another 3, that's 5. So I would need 2.5 right there. Rather than do that, let's maybe double everything. Yeah, let's double things. So 4 there, that's 12, so that'd be 12 hydrogens there. 4 nitrogens, so 4 nitrogens. So on this side I have 6 and 4, that's 10. So if we put a 5 there, now I've got it balanced. Okay, so let's find moles of ammonia. So moles of ammonia, mass over molar mass. The mass is 3.25 grams. The molar mass, let's do ammonia over here. 1401 is nitrogen, and 3 hydrogens would be that. So it would be 1704. So 1704 grams per mole. And I divide those. 3.25 divides 17.04. Yep. So I come up with 0.190727 moles of ammonia. Okay, now let's figure out how many moles of oxygen I have. Same formula. Mass is 3.50 grams. Molar mass of oxygen, it's O2, so that's 32.00 grams per mole. So 3.5 divide 32, 0.109375 moles of oxygen. Okay, now I can start comparing. But the ratio here is 4 to 5. So let's just start. I always just start with this first one here. So let's start with that and say, see how many moles of oxygen I would require. So so I have 0.190727 moles of ammonia. So let's see how much oxygen that would require. So I put my 4 moles of ammonia on the bottom and 5 moles of oxygen on the top. So if I used up all of the ammonia, let me get that number again, 3.25 divided 17.04 is that, and now I have to times that by 5 and divide it by 4. So to use up all of this, I would need 0.2384 moles of oxygen. But I only have this much. Therefore, let me just write that. But I only have 0.09375. Therefore, oxygen is the limiting reactant. Okay, so how many grams of NO2 are formed? So I'm going to right now forget about the ammonia stuff. I'm just going to focus on my oxygen and my nitrogen monoxide. Okay, those are the two I'm going to focus on. So if I'm doing the river, they say grams, so I'm starting here and going there. So I need to figure out how many moles of oxygen I have, because that's my limiting reactant, and I've done that right here. So that there is step 1. And then step 2, to go across the river, let's do step 2 down here. Let's write the number of moles of oxygen I have, 0.109375 moles of oxygen, multiplied by, I have 5 moles of oxygen required to produce 4 moles of nitrogen monoxide. Okay, so let's take that and do that. So 0.109375 times 4 divide 5. 0.0875 moles of nitrogen monoxide. And so step 3 will be taking it back to grams. So taking the moles of nitrogen monoxide, converting it to mass of nitrogen monoxide. Formula, moles is mass over molar mass. So to arrange that, it'd be mass is equal to moles times molar mass. The moles I just got 0.0875 moles times the molar mass of nitrogen monoxide. Let's figure that out. Nitrogen is 1401 and oxygen is 16. Notice I just used one oxygen because in the equation here there's just one oxygen. So that'd be 30.01. So 30.01 grams per mole. So that number that I just got times 30.01. 2.62625.875 grams. Rounding, probably 3 sig figs everywhere. Yep, so 2.63 grams nitrogen monoxide. Okay, good. So I've figured out which is the limiting reactant, and I figured out how much of the nitrogen monoxide is formed. Now the last question, it says how much of the excess reactant remains, and the excess, as you'll recall, is this ammonia right there. And they want to know how much of that is left over. So I'm just going to move that up just a touch. So if I want to know how much is left used up, then it shouldn't be too hard. It's a little bit of stoichiometry. So this is how much, how many moles of ammonia I have, and this is, but that's, I've got excess, right? So if I'm using up this many moles of oxygen, I should be able to figure out how many moles of ammonia get used up too. I know I'm going to have extra, but I can do that just using one of those step 2s where you convert from moles to moles. So let's do that. So find excess remaining. That's what we're doing here. So the moles of oxygen I have is 0.109375 moles of oxygen. And let's multiply by our ratio. Our ratio is 5 moles of oxygen for every 4 moles of ammonia. Okay, let me multiply that out. So 0.109375 times 4 divide 5. Oh, I guess I already did that, but this one is the same because they were both 4s. Their coefficients were both 4s. Whoops. 0.875 moles of nitrogen monoxide. So that's how much would get used. This is how much would get used. So to figure out how much is left, then I just subtract, because that's how much got used. And we'd use a different color here, sorry. Let's use white. So this is how much got used, and up here, this is how much you have. So to figure out how much is left, we'll just subtract the two. So I have 0.190727 moles minus how much gets used up, 0.875 moles. So what's that come out to? 0.190727 minus 0.0875. So that's given me 0.103227 moles left, just sitting in the beaker, because they didn't get used up with the oxygen. Let's just see if that's right. Oh yeah, 0.103. And then they say, I guess they say how much of it's left over. So you could just say I've got that many moles. But it does make sense to convert it to grams. So let's use our formula. Mass, mass is equal to moles times molar mass. So the moles are 0.103227 moles. And the molar mass of ammonia was 1401 and 303, 1704 times 17.04 grams per mole. So that number I had there times 17.04, 1.76 I'm calling it, 76 grams of ammonia left. Okay, hopefully that helps you with that question. That's a lot of color on the page.